We have been factoring quadratic equations where a is 1, and today we're going to look at some more difficult quadratics where a is larger than 1. And many times we can still factor, so we're going to try. Our first step is to get one side equal to 0, just like we've been doing. So that gives us 10x squared minus x minus 3 equals 0. I would use guess and check. I like guess and check, and that's something I'm good at. But there are some students that really struggle and they need kind of another method. So if it will factor, it does always follow a pattern. You can ask yourself what multiplies to a times c. So in this case, the a is 10 and the c is -3. So we're asking ourselves what multiplies to give us -30. And there's lots of options. You could start listing them. 1 times -30, 2 times -15, 3 times -10, 5 times -6. And I could keep going because there's a -1 times +30 and so on. But what I'm looking for is which pair add to b. So the first question you ask yourself, what multiplies to give you -30? And we got that by multiplying a and c together. Your second question should be which pair add to b? And in this case, b is a -1. So notice right here, my +5 and a -6, that multiplies to give me -30 and adds to give me -1. The -1 is the number in front of my linear term. So now what I'm going to do, I'm going to keep the first term, 10x squared. I'm going to keep the last term, that -3, and I'm going to rewrite the middle. So we're going to rewrite the middle term using the +5 and -6. So I'm going to write this +5x minus 6x. Notice this -1x, I have just rewritten it using two terms. It's still -1x, 5x minus 6x. So really, it's kind of like 1/2 is the same as 2/4. I've just picked a different form to write that -1x. But now I have 4 terms. And so when I have 4 terms, I can use factoring by grouping. So what I'm going to do, hopefully I can erase this a little better. So I'm going to group the first 2 and pretend like that's my only problem. So if I just look at those first 2 terms, ask yourself, how do I factor? And you always go through the steps. Does it have a GCF? Yes. So the GCF here is 5x. And so then what would be left? Remember, factoring is really the opposite of distributing. So I would have a 2x plus 1, because if I distributed that 5x, I would get what I started with. Then when I group the second 2, notice that both terms are negative. So that should give you a hint that you definitely want to factor out a negative. But then you can also factor out a 3. Now anytime this first term is negative, I will always factor out a negative. Okay, so then we need to figure out what goes in that parentheses, and -3 times a 2x would give you that -6x, and -3 times a +1. And so notice when I have factored by grouping, I now have what I consider a big GCF. Notice that both pieces have a 2x plus 1 in common. And then you've got to see, okay, what's left over? If you were to distribute and get what you started with, you would need a 5x right there to get this piece. And then I would also need a minus 3 to get this final piece. And then I have factored. Now keep in mind I am still needing to solve this equation. So all along I could have just brought down that equals 0. Now I've got my two factors and I'm going to set those equal to 0 to find my solutions. And this is something that we've been doing. So just set each of your factors equal to 0 and then solve. So your first solution is going to be a negative 1/2. Just going to put that right here. And then your second solution looks like it's going to be a positive 3/5. And keep in mind you can check these because they're equations. Plug it back in to make sure that it works.